Um, but today I'm going to talk about drought and how this ultimately affects tree death. So I know most people have kind of focused on plants so far. Trees react differently to water than plants do. So I'm going to talk about trees specifically. Um, so I know this group maybe isn't that familiar with this diagram, but this is a very popular and up and coming concept originally taken from Paul Mannion in his book talking about disease decline spiral, which kind of conceptualizes how a tree reacts to its environment and all these compounding factors which ultimately lead to tree death. So it's not just one factor that causes tree death, it's, you know, a set of factors that ultimately contribute to death. So there's been a lot of different people that have taken this concept and made it their own. Um, the first time it was called the tree mortality spiral was a paper by Franklin in 1987, and he was talking about natural dug firs in a natural system, and he took that decline spiral and made it a mortality spiral, which is what we generally call it today in the tree industry. But it's been adapted a lot by a lot of different people to include a lot of different things. So some people would like to add a human element to it and say, humans play a big part in, especially in urban settings, and which ultimately contribute to tree death as well. So there's been a human element added to it and other interpretations of it, adding time, adding a few other possible factors in there that lead to tree death. But it's a very, since its introduction, it's been a very popular concept. And I really like this, when I'm doing talks and talking with clientele and everybody, I really like to use this concept as well. But what you can see here with all of them that I've showed you so far is there's essentially been a set of three factors that they talk about: predisposing, inciting, and contributing factors that ultimately lead to tree death. Um, so just to kind of talk about those real quickly, um, the predisposing factors, these are the long-term, slowly changing kind of chronic factors that really you don't have a lot that you can change on these. Um, so these are things like the genetic potential of a tree, its age, whether it's infected with the virus, and site conditions, the soil, nutrition, and the climate that it's planted in. All those things are ultimately very hard to change. And if you are trying to change them, it takes time. Um, and all these kind of predisposing factors affect a tree's ability to withstand any potential injury or other factors later on. And so if we go back to the decline spiral, looking at all the different things that are listed there, you can see a lot of different other examples that I didn't list here. But ultimately, these predisposing factors kind of weaken the tree um, and make it more susceptible for these inciting factors, these short-term occurrences, to come in and really start causing the tree to decline. So these are things like insects, drought, which I'm going to go into a little bit more later, frost. In urban settings, we have human disturbances like excavation. And these are what really kind of cause the first signs that we see of dieback or decline of a tree. And so these inciting factors, they're continuing to weaken the tree. So now the tree has to use its resources and respond to all these different things, and it's using all those carbohydrate stores, which make it more susceptible to these contributing factors, these opportunistic organisms to come in and weaken the tree and ultimately kill it. So these are things like your canker fungi, so your Botryosphaeria fungi, bark beetles, boring beetles, root rot fungi, things like that. And this is what, ultimately leads to the tree dying. All right, so drought. What is drought? So drought is just a period of drier than normal conditions that can result in water-related problems. So there's different definitions of drought. There's different types of drought. So we have a meteorological drought, which is just the lack of precipitation, or you can have what we call an agricultural drought, which is a lack of soil moisture. So maybe there is rain, but there's no moisture in the soil. And you also have a hydraulic drought, which is reduced stream flow or very low groundwater levels. So there are different types of drought, and it's important just to kind of know that even though you may have a lack of precipitation, you still may have adequate soil moisture, so you're not dealing with the plants may not be experiencing the same drought that we think is going on, or vice versa. So maybe we have rain, but we still don't have that soil moisture that plants can use to actually grow properly that they need. So it's important to think about drought in a variety of ways and how that's going to affect a plant or tree. So just talking about drought stress, what does drought do to plants, to trees? The first thing is this, how do plants and water react? So under drought stress conditions, you have a lower relative water content in trees, which is going to reduce your leaf water potential, your stomatal resistance, your transpiration rate's going to go down, and then it's going to increase leaf temperature and canopy temperature. So if you kind of look at that picture on the slide here, you can see that, under nice, happy, healthy conditions with lots of soil moisture, the tree is readily able to take up water and keep those cells nice and pressurized with water. So that water fills up the cells, cells are happy, healthy, the tree can actually grow. But once you get into drought conditions, all the water content in the cells starts to be reduced and the cells start to decrease in size. And I'm going to throw up a term here on this next slide called xylem cavitation. And in trees, when we're talking about drought stress and drought causing trees to die, this is what actually, in trees anyway, not so much necessarily in smaller shrubs and things like that, this is what causes trees to die from drought when we're talking about just drought killing trees. So what happens under drought conditions, extreme drought conditions, is the water potential in the xylem falls below a specific threshold and it starts to take in air into the xylem. And what happens is all these air bubbles essentially form an embolism in the xylem. And now the xylem can no longer take up water and provide that water to the rest of the tree. And, as the tree gets more and more of these embolisms throughout the xylem, eventually there's no more water going to the canopy of the tree and the tree dies as a result. So it's not, it's not just the lack of water itself, but, there's actually this embolism, all this air that ultimately chokes the tree to death from lack of water. But, there's a lot of effect of drought stress on essentially every aspect of a tree's normal process. So drought causes reduced growth at all stages, from seed to maturity. So under drought stress, seeds aren't going to germinate properly because there's just not the right environmental conditions for them to grow. So seeds are going to wait until they can have that soil moisture that they need to grow. But then as they get older, drought stress causes, we talked about that loss of turgor pressure, which leads to cells not elongating properly, which reduces growth. Cells also need water for mitosis so they can duplicate, so they can have cell division. And without that cell division, plants also aren't growing. So essentially, drought affects every aspect of a plant's normal function. Going into photosynthesis here, you can see that very complicated diagram there on all the different ways that drought affects the normal operation of the tree's life. So it's affecting photosynthesis in a ton of different ways. You know, decrease in leaf expansion. The photosynthetic machinery itself is reduced and impaired because it doesn't have the water. It can't have those processes perform correctly to photosynthesize the right chemicals and everything within the leaf. And you also get premature leaf drop, so you're reducing the leaf area itself for photosynthesis. So drought affects every aspect of a tree, slowly reducing its carbohydrate stores and its potential to fight off any potential pathogens or insects. Even nutrient uptake limits nutrient uptake in plants, so it doesn't have everything that it needs for those building blocks to build what it needs to build new leaves. We have different ways that plants take in nutrients, whether it's mass flow with water as that's coming into the tree, or using that water as kind of that buffer between the soil particles, so the tree, so those root hairs can actually take in those necessary nutrients from the soil. All right, so now going back to our mortality spiral here and getting back to how drought plays a part in tree death. So if we're looking at our spiral here, we're looking at drought is generally listed as kind of an inciting factor here. So drought is never, we can have prolonged drought, but it's essentially a kind of one-off event, right? So drought happens, we get rain, drought ends. It's not this generally chronic condition. So drought is here in the middle. And drought can cause a lot of other problems, but drought is also exacerbated by these predisposing factors that we have here. So in our urban environments, we have, like Don mentioned, we have compacted soil.
Hello?
We have all these different
Looks like
issues. And so there's a lot that goes into how drought is interacting with all these other issues. So if we look at how plants interact with each other and how drought plays a part in that, plants are competing with each other for water, light, nutrients. And so there's this constant demand. So a larger tree is going to require more water. So under drought conditions, under these, low water conditions, a bigger tree is actually going to suffer more drought stress than a smaller tree, because that bigger tree needs a lot more water. It's going to go through those carbohydrate storage a lot quicker than a smaller tree is, just due to its size. But trees can actually also help each other under stressful conditions such as drought. So you have what we call a nurse plant. So these bigger trees actually provide shading to smaller trees, and actually help cool that tree off, reduce its transpiration. So those smaller trees can actually survive a little bit better under stress, under these stressful conditions. And trees can actually also help bring water from lower in the soil and actually bring it up to higher levels, so that shallower rooted trees can actually use that water. And we call this hydraulic lift. And what happens is deeply rooted trees actually kind of help move that soil up or move that water up through the soil, and make it available higher up in the soil profile for shallower rooted trees and for itself to actually access, with more root hairs and surface area there. But as we know, ultimately, insects come along. Insects play a big part, especially with drought stressed trees. While there is a lot of mutualism with plants and insects, pollination, seed dispersal, there's also some protection that goes on with different species. There's a lot of antagonism that goes into insects and plants. And this is ultimately what we care about in our mortality spiral, right? Is we care about these insects, this herbivory that's going on with insects and trees. But, just to throw it on here, there are plants that feed on insects, right? So you get that insectivory as well, but just not as common. But generally, when I'm thinking of mortality spiral, I kind of think of kind of that ultimate death as being impacted by microbes. So microbes are very important in a tree's life. There's a ton of symbionts of trees. Without microbes, essentially trees wouldn't be able to function normally or survive at all. They have those mycorrhizal fungi which help them in the soil to get that water, to get those nutrients. But they also have endophytic fungi living within the tree itself, which are helping it carry out a lot of those kind of natural processes that the tree goes through. But then it's kind of once those endophytic fungi or other fungi can come in and be pathogenic, that ultimately there's a negative impact on trees. And that's kind of what we mostly think about, is that negative impact of these microbes rather than all the benefits that they provide. But ultimately, a lot of tree death occurs from these pathogenic fungi, these secondary fungi that come in and kill trees. Just to throw another term out at you guys here that you guys will probably experience, especially in these summer months, in Southern California, is this term apoplexy. And what this is seemingly healthy plants rapidly wither and die within a short time period. So generally, it could be as quick as within a few days, or it could be, when we're talking about trees, it could be a period of time over 3 to 4 months. And what happens is there's typically some kind of event where an organism enters a plant. Generally, that we think about this as through a pruning wound. Some kind of microorganism gets in there and is kind of endophytic in the tree. So it's there, it's growing. It may be helping the tree, or it may just kind of be duplicating and replicating within the plant, not causing any harm. And then you get to some critical phase, which is generally either drought or heat. And that, endophytic organism becomes pathogenic. And because it's already duplicated and so far spread within the plant, that change, that signaling within the tree, going from, hey, this is a good guy to a bad guy, now I need to have all these reactions, because that organism is so established within the tree, that switch from good to bad kills the tree in a very rapid time frame. So the tree reacts by clogging its vessel elements, the xylem, the phloem, and ultimately the tree just ends up killing itself because of this severe stress that's placed on it. And so we see that a lot of times in the summer, where we get these hot, dry conditions, and you'll see plants rapidly dying. You're like, what happened? How did it die so fast? It was green last week, now it's completely dead. And this is what happened, is there was already something well established in the tree, and it just took that one extreme stressor to flip a switch within the plant, and ultimately that leads to the plant killing itself. So what this brings us all back to is this plant stress hypothesis, where plants under stressful conditions are more susceptible to attacks by insects and diseases. So we know drought causes stress on every aspect of a plant's life, and this reduces a tree's ability to produce energy. So it can't photosynthesize, it can't get the nutrients that it needs. And so the plants can't respond to any attacks from it by these insects or other organisms. But just to throw this out here is kind of a side note that um, drought can affect insects as well and how they attack it. So, if you see here, essentially galling insects and chewing insects actually have a negative impact by drought stress on trees. So just quick side note on that. But we care about here is going back to our tree mortality spiral again and how drought fits into this. So in our urban environments, we have all these predisposing factors that we generally can't change, right? So we're dealing with our urban planting site. We can't make our urban site, we can't make it a nice natural forest. When we have a tree, when we're planting our plants, they're at a certain age already. We can't change that. Their genetic potential is already predetermined. Generally, our soil compaction, if you're at a planting site, are you going to go through and air spade down 6 feet, really loosen up that soil a lot? No. Your soil fertility, sure, you can go through and add fertilizer and things like that, but generally, the fertility of the soil overall as that plant grows is kind of already set. Your soil structure, climate, those are things you can't really change. And drought is now building off of that. So we already have trees that are stressed because of our urban planting sites, and now drought comes in, stresses them even more, and that makes them more susceptible to insects, pathogens, soil disturbance. Pruning, as we're pruning, now we're weakening the tree even more. We're taking away even more carbohydrate stores for them and really making it hard for that tree to just live. Um, and ultimately, what happens is you get these contributing factors like those canker fungi, the wood boring insects, or those root rots to come in and kill the tree. So it's just all these compounding factors, right? Each one of these things slowly stresses out the tree, causes the tree to divert resources from growth and defense into responding to other things. And ultimately, you have this spiral towards death. And we want to minimize that as much as we can. I work with a ton of people. I always just like to throw the slide up at the end of everybody that I work with. So quick slide of a ton of people, and I may have time for some questions.